This lecture is about the text-based prediction. In this lecture, we're going to start talking about mining a different kind of knowledge, as you can see here on this slide. Namely, we're going to use text data to infer values of some other variables in the real world that may not be directly related to the text or only remotely related to text data. So this is very different from content analysis or topic mining, where we directly characterize the content of text. It's also different from opinion mining or sentiment analysis, which still have to do with characterizing mostly the content, only that we focus more on the subjective content, which reflects what we know about the opinion holder. But this only provides limited view of what we can predict. In this lecture and the following lectures, we're going to talk more about how we can predict more information about the world. How can we get sophisticated patterns of text together with other kind of data? It would be useful to first take a look at the big picture of prediction in data mining in general, and I call this data mining loop. So the picture that you're seeing right now is that there are multiple sensors, including human sensors, to report what we have seen in the real world in the form of data. And of course, the data are in the form of non-text data and text data. And our goal is to see if we can predict some values of important real-world variables that matter to us. For example, someone's health condition, or the weather, or etc. So these variables would be important because we might want to act on that. We might want to make decisions based on that. So how can we get from the data to these predicted values? Well, in general, we'll first have to do data mining and analysis of the data. Because we, in general, should treat all the data that we collected in such a prediction problem setup, we are very much interested in joint mining of non-text and text data. We should mine all the data together. And then through the analysis, we generally can generate multiple predictors of this interesting variable to us, and we call these features. And these features can then be put into a predictive model to actually predict the value of any interesting variable. So this then allows us to change the world. And so this basically is the general process for making a prediction based on data, including text data. Now, it's important to emphasize that human actually plays a very important role in this process, especially because of the involvement of text data. And so human first would be involved in the mining of the data. It will control the generation of these features, and it also help us understand the text data, because text data are created to be consumed by humans. Humans are the best in consuming or interpreting text data. But when there are, of course, a lot of text data, then machines have to help, and that's why we need to do text data mining. Sometimes machines can see patterns in a lot of data that humans may not see. But in general, humans would play an important role in analyzing text data in all applications. Next, human also must be involved in predictive model building and adjusting or testing. So in particular, we will have a lot of domain knowledge about the problem of prediction that we can build into this predictive model. And then next, of course, when we have predicted values for the variables, then humans would be involved in taking actions to change the world or make decisions based on these predicted values. And finally, it's interesting that a human could be also involved in controlling the sensors. And this is so that we can adjust the sensors to collect the most useful data for prediction. So that's why I call this data mining loop, because as we perturb the sensors to collect the new data and more useful data, then we will obtain more data for prediction. And these data generally would help us improve the prediction accuracy. And in this loop, humans will recognize what additional data need to be collected. And machines would, of course, help humans identify what data should be collected next. In general, we want to collect data that are most useful for learning. And there is actually a sub-area in machine learning called active learning that has to do with this. How do you identify data points that would be most helpful for machine learning programs if you can label them? Right? So in general, you can see there's a loop here from data acquisition to data analysis or data mining to prediction of values and to take actions to change the world and then observe what happens. And then you can then decide what additional data have to be collected by adjusting the sensors. Or from the prediction errors, you can also know what additional data we need to acquire in order to improve the accuracy of prediction. And this big picture is actually very general, and it's reflecting a lot of important applications of big data. So it's useful to keep that in mind while we are looking at some text mining techniques. So from text mining perspective, and we're interested in text-based prediction. Of course, sometimes text alone can make predictions, and this is most useful for prediction about the human behavior or human preferences or opinions. But in general, text data will be put together with non-text data. So the interesting questions here would be, first, how can we design effective predictors? And how do we generate such effective predictors from text? This question has been addressed to some extent in some previous lectures where we talked about what kind of features we can design for text data. And it has also been addressed to some extent by talking about the other knowledge that we can mine from text. So for example, topic mining can be very useful to generate patterns or topic-based indicators or predictors that can be further fed into a predictive model. So topics can be intermediate representation of text that would allow us to design high-level features or predictors that are useful for prediction of some other variable. It may be, although it's generated from original text data, it provides a much better representation of the problem, and it serves as more effective predictors. And similarly, sentiment analysis can lead to such predictors as well. So those other data mining or text mining algorithms can be used to generate the predictors. The other question is, how can we jointly mine text and non-text data together? Now, this is a question that we have not addressed yet. So in this lecture and then the following lectures, we're going to address this problem, because this is where we can generate the much more enriched features for prediction, and allows us to reveal a lot of interesting knowledge about the world. These patterns that are generated from text and non-text data themselves can sometimes already be useful for prediction, but when they are put together with many other predictors, they can really help improving the accuracy of prediction. Basically, you can see text-based prediction can actually serve as a unified framework to combine many text mining and analysis techniques, including topic mining and any content mining techniques or sentiment analysis. The goal here is mainly to infer values of real-world variables. But in order to achieve the goal, we can do some other preparations, and these are subtasks. So one subtask could be mine the content of text data, like topic mining. And the other could be to mine knowledge about the observer, so sentiment analysis or opinion analysis. And both can help provide predictors for the prediction problem. And of course, we can also add non-text data directly to the predictive model. But then non-text data also helps provide a context for text analysis, and that further improves the topic mining and the opinion analysis. And such improvement often leads to more effective predictors for our problems. It would enlarge the space of patterns of opinions or topics that we can mine from text, as we will discuss more later. So the joint analysis of text and non-text data can be actually understood from two perspectives. In one perspective, we can see non-text data can help text mining, because non-text data can provide a context for mining text data, provide a way to partition text data in different ways. And this leads to a number of techniques for contextual text mining. And that's to mine text in the context defined by non-text data. And you can see this reference here for a large body of work in this direction. And we're going to highlight some of them in the next lectures. Now, the other perspective is text data can help non-text data mining as well. And this is because text data can help interpret patterns discovered from non-text data. Let's say if we discover some frequent patterns from non-text data. Now we can use the text data that are associated with instances where the pattern occurs, as well as text data that are associated with instances where the pattern doesn't occur. And this gives us two sets of text data, and then we can see what's the difference. And this difference in text data is interpretable because text content is easy to digest, and that difference might suggest some meaning for this pattern that we found from non-text data. So it helps interpret such patterns. And this technique is called pattern annotation. And you can see this reference listed here for more detail. So here are the references that I just mentioned. The first is the reference for pattern annotation. The second is Qiao Zhumei's dissertation on contextual text mining. It contains a large body of work on contextual text mining techniques.